I'm going to explain about pulse amplitude modulation. Modulation means you know that the amplitude of the carrier is varied according to the message signal. For example, if you take an image, so this is an message, image is a message converted into electromagnetic wave. So this is an electromagnetic wave, EM wave. So image is converted into message signal, M of t. Assume that it is M of t denoted with M of t. So this I want to modulate. So you can take the signal, carrier signal. So this is an carrier pulse. This is carrier pulse. This is the carrier pulse. So by using this, I can modulate this signal. So after modulation, so this amplitude of the carrier is varied. This carrier signal is used to modulate the message signal. This is the carrier, pulse carrier. So this pulse is varied according to the message. Whatever the message is there, so according to that, this message carrier signal is varied. Carrier pulses are varied. So this is an amplitude modulated signal. After modulation, denoted with S of t. S of t. This is the pulse is varied according to the message signal. Just assume this is the signal, message signal. So according to that, so the pulses are varied. So this is an pulse amplitude modulation. The carrier pulse is varied according to the message signal is called as pulse amplitude modulation. Generally, it is named as pulse modulation. So I will explain anyhow. We can see this. This is the message signal. Just assume. So this is the image, and this physical image is converted into, that is EM wave, electromagnetic wave. Of course, it filters here. So as required frequency signal, I can send to 3 through low pass filter. So here this is a required message signal, and then from the pulse generator we are generating the pulses. So here it will multiply, and after that, so we'll get modulated output here. This is a modulated output, pulse amplitude modulated signal. So generally these pulses are used for to control the signals in microcontrollers, or else it is used to control the LED bulbs. So everywhere it requires that is pulse signal is required to control all the signals or all the chip devices everywhere. So this pulse is important to control the signals. That is the applications for the PM signal, pulse amplitude modulated signal. Generally, here you can see this. This is the equivalent just assumption. So this is an image equivalent signal, or else it is also assumed that it is an you said hello. So this is the equivalent hello signal after conversion from physical to message. So this is an carrier signal C of t. So C of t, and after modulation, this is the pulses of the carrier is varied according to the message signal. This is an PM, pulse amplitude modulated signal. So coming to the types of modulation, you can see this one's just so continuous wave modulations or amplitude modulation or frequency and phase modulation. That is also named as that is angle modulations. This is an continuous modulations, continuous wave modulation AM. That is, we know that amplitude modulation, frequency modulation, or else phase modulations or continuous modulation. Coming to the pulse modulations, so here you can see this analog modulation. This is also here you can see this. It is, and PAM, pulse amplitude modulation, and PWM, pulse width modulation, and PPM, pulse position modulation. So these are also analog modulations. Of course, AM and FM and PM also analog modulation techniques. Coming to here, digital modulation techniques are there. So that is also named as, that is of course ASK, amplitude shift keying, and FSK, frequency shift keying, and that is phase shift keying, PSK. These are the digital modulation techniques. Same thing, we can say this, the message signal is multiplied with, that is carrier signal, and after that the modulated output will get, that is named as S of t. Here this is the advantage, main advantage. It controls the all the signals. So by using this PM signal, we can control the signals, and we can use it in LED lightning. So just you have seen that by using this, we can control the LED bulbs, LED lightnings. So, and coming to the advantage, we can, it is easy to modulate and demodulate, and circuits are very easy to generate, but it requires high bandwidth. That is the only the disadvantages. So, and of course the power requirement, power consumption also very high. So thank you.